Good morning, students. This course unit will involve two branches, bonding and periodicity. I'm going to take you through bonding, and my colleague will take you through periodicity. This course will look at ionic bond, covalent bond, some theories like a valence shell electron pair repulsion theory, valence bond theory, VBT, molecular orbital theory, but it will not look at hydrogen bond because you studied that in first year. What is a chemical bond? A chemical bond is the force of attraction that binds the ion molecules or atoms in different chemical species. Why do you think elements form chemical bond? There are two concepts. The first concept is the concept of lowering energy. Usually the process of chemical bonding between the atoms decreases the energy of the combining atoms and gives rise to the formation of a system which has got a lower energy. The moment the system has got a lower energy, it means the formed compound is stable. Another concept is the concept of octet rule or rule of 8. When atoms of elements combine, the electrons in their outermost orbitals arrange themselves in a such way that they achieve a stable configuration, resulting into a chemical, the stability of a chemical bond. A chemical bond may be ionic, covalent, coordinate, metallic, van der Waals, or hydrogen bond. In this topic, we are going to look at an ionic bond, covalent bond, metallic bond, but not van der Waals or hydrogen bond because we looked at them in the first year extensively. So what is an ionic bond? An ionic bond is the bond formed by complete transfer of one or more electrons from a highly electropositive element to a highly electronegative element. Usually the highly electropositive element is a metal. And the metal loses electrons to gain a positive charge. When it has lost electron, that element is referred to as a cation. While that one which has gained electron, which is more highly electronegative, will acquire a negative charge on receiving the electron, and it will form an ion, or it is referred to as an ion. The electrostatic force of attraction that binds the cation and an ion in a compound is called an ionic bond. Sometimes it is also called electrovalent bond. Conditions necessary for the formation of ionic bond. There are mainly three conditions. The first one, the metal must have a low ionization energy. When the ionization energy is low, the tendency of losing electron will be easier for the cation or for the metal to attain a positive charge. And the second one is the electron affinity. The electron affinity of a nonmetal must be high. The nonmetal must be able to acquire the donated electron from the metal. So the electron affinity for the nonmetal must be high. The last one is the lattice energy. The amount of energy released when appropriate number of cations and anions are brought from infinity to their respective lattice site to form 1 mole of an ionic compound. Usually lattice energy depends on electrostatic force of attraction, which is given by the charge on the cation times the charge on the anion divided by the separation between the cation and the anion. So when you look at this equation, when the separation is small, automatically the electrostatic force of attraction be high, provided the charges on the combining species are high, the cation and anion. So if the electrostatic force of attraction is high, automatically the lattice energy will be high, as we shall see in the following slides. Therefore, for the energy to be high, cation and anion should have a small size, as said earlier, and it should have a high electric charge. Lattice energy can also be defined as the amount of energy required to break 1 mole of an ionic solid into its constituent ion. So to break this electrostatic force of attraction between the two ions, we need lattice energy, which breaks them into their constituent gaseous ion, the positive and the negative. Theoretical calculation of lattice energy. In an ionic crystal, the following Coulombic attractions are possible. There are 2 Coulombic interactions. 1, electronic force of attraction between the oppositely charged ion. Another one is the repulsive interaction because of the interpenetration of the electronic crowd within the molecule. The electrons themselves, within the atom, the electrons themselves repel each other. So because of the 2 interactions, because of the 2 interactions, the electrostatic force and also the repulsive interactions, Born-Landes came up with an equation which he called Born-Landes equation. This equation helps us to calculate the lattice energy theoretically, and it involves having the Avogadro's number, which is multiplied by Medranga constant, then times the charge on the cation and that one on the ion, then times the electronic charge divided by the sum of the radii of the cation and the anion, bracket times 1 minus 1 over n, where n is the Born exponent. This Born exponent must be greater than 1, but it is different for each given ionic compound. In conclusion of the Born-Landes equation, the higher the charge on the cation and anion, the greater is the magnitude of lattice energy. Why? Because when we go back to the equation, if the charges are high for both cation and anion and their separation is small, automatically the lattice energy will be greater. So therefore, the lattice energy for the univalence and univalence species like lithium and fluorine is less than the univalence and bivalence. For example, calcium and fluorine is also less than bivalent species. An example is magnesium sulfide. For this case, the bivalent species have got a higher lattice energy than the univalent species. Lattice energy can be also calculated experimentally by Born-Haber cycle. Since you studied this Born-Haber cycle in first year extensively, I will not cover it in this topic, but I can give an assignment, which is construct a Born-Haber cycle for sodium chloride crystal and define the terms used in the cycle. Does lattice energy has an application? Yes, it can help us to predict the stability of an ionic solid. Remember, lattice energy depends on electrostatic force of attraction between the two ions. So if the electrostatic force of attraction is high, automatically the lattice energy will also be high. And the moment the electrostatic force of attraction is high, that compound is stable. It helps in determining whether the compound will be soluble or not. How? You compare the hydration energy of that solid, ionic solid, with the lattice energy. If the lattice energy is greater than the hydration energy, it means that compound is insoluble. However, if the hydration energy is greater than the lattice, automatically the compound is soluble. Characteristics of ionic compound. How can you tell that this is an ionic compound? One, you compare the melting point and the boiling point of that compound with other compound. If the melting point and the boiling point is high, it means that is an ionic compound. Therefore, ionic compounds have got a high melting point and boiling point. Volatility. They are non-volatile. That's why they have a high melting point and boiling point. Conductivity. They are good conductor of electricity in aqueous solution, because in aqueous solution, the high dielectric constant of water reduces the forces of attraction, and hence the ions are set free to conduct electricity. But in a solid form, the ions are not soluble, so the ionic compound does not conduct electricity in a solid state. Again, they are good conductor in molten or in fused state. Why? The kinetic energy of the ion overcomes the forces of attraction between them, and they become mobile. So they can move and apply the potential. Solubility. You remember the principle of like dissolves like. So ionic compounds are soluble in polar solvents, e.g. water, but they are insoluble in non-polar solvents. An example of a non-polar solvent is benzene or carbon tetrachloride. So that is all with ionic bond. Let us look at the covalent bond. A covalent bond is the bond formed by sharing of one or more electrons. A covalent bond formed between two electronegative atoms. There must be atoms with the same electronegative. A covalent bond may be single or double, as in the case of oxygen, triple, as in the case of nitrogen molecule, depending upon the fact that whether one or two or three pairs of electrons are shared between the two atoms. An example is hydrogen. The electron configuration for the first hydrogen is 1s and another one 1s, both the orbitals having one electron in each. When they combine, they form a stable configuration of 1s2, the helium, and the bond between them is a single covalent bond. Factors favoring the formation of a covalent bond. Let us consider atoms A and B. So these two atoms must have a high value of ionization potential so that they don't lose electron. Another one, electronegativity of both atoms must be the same or equal or slightly different from each other. An assignment, discuss the properties of a covalent bond. Types of a covalent bond. There are mainly two types. We have a non-polar covalent bond and a polar covalent bond. So what is a nonpolar covalent bond? This is the bond formed between the same type of atom. In such cases, the bonding pair lies exactly in between the atom. An example is the hydrogen bond, oxygen bond, nitrogen bond, and so many others, provided they have the same electronegativity. A polar covalent bond. This is the bond formed between two dissimilar atoms. The atoms have to be different with different electronegativity. An example is hydrogen chloride. Since chlorine is more electronegative than hydrogen, it will attract the bonding electrons towards itself. The moment the bonding electrons are pulled towards chlorine because it is more electronegative, you know, electronegative element has got a tendency of attracting or accepting electrons. It will create a partial positive on hydrogen and a partial negative on chlorine because of the excess electron pulled. As an assignment, outline 7 differences between polar and non-polar covalent compound. Let us look at the sigma and the pi bonds. What is the sigma bond? This is the bond formed from end to end, all head-on overlapping of the orbitals. The extent of overlapping is maximum in a sigma bond. Therefore, the bond formed by a sigma bond are always strong. We have SS overlap. These ones lead to a formation of a sigma bond. PP overlap. They also lead. We have also an S and P overlap, as we shall see in the slides, in coming slides. Examples to show the formation of a sigma bond. We can look at an example of hydrogen. Hydrogen leads to the formation of an SS overlap. The electron configuration of hydrogen is 1s. Each hydrogen is having an unpaired electron in an orbital. So these unpaired electrons overlap with each other along their axis to form a 1 hydrogen sigma bond. Similarly, for ammonia, they also result into the formation of a sigma bond. Water and fluorine. You can pause and read more. As an assignment, draw orbitals to show the formation of sigma bond or bonds in the following molecules or molecule: hydrogen, ammonia, water, and fluorine. What is a pi bond? A pi bond is the bond formed by lateral overlap or side-to-side overlap of the 2 half-filled orbitals belonging to the valence shell of the 2 combining atoms. Side-to-side overlap. These 2 are overlapping, resulting into the formation of a pi bond. Differences between a sigma bond and a pi bond, these ones can be generated from the discussion you have had. We said the sigma bond is formed from end-to-end overlapping, while a pi bond is formed by lateral overlapping. Then the extent of overlapping is maximum in a sigma bond, and due to lateral overlapping, the bond is weak. A sigma bond is less reactive. Remember, it has formed a stronger bond, while a pi bond is more reactive. Electron density is maximum along with the internuclear distance in a sigma bond, while for the pi bond, electron density is maximum above and below the internuclear distance. We are going to look at hybridization in next time. for lesson 2.